going to explain how to do assignment number 2. So attached to the assignment, there should be a physics notebook that has been copied for you. And there's also a link to the prompt for the notebook. So page 1, just put your name. Page 2 is where we'll have our table of contents, and this page is important because it has a link to the prompts, and it also has a link to my sample page. I already have the prompts open on my screen, but you can also open them in preview, which is nice because you can read the prompt as you complete the notebook entry, and you can resize it by clicking that. So your document will be blank, and but this is what it can look like afterward, and you'll have to add a bit extra info, but let me read you the prompt. So draw the results of the 4 collisions. So we have 2 blocks on ice, and you can assume it's a frictionless surface. We have our green block. Sorry, I think my mouse might have been over the wrong thing. All right, we have our green block moving at 2 meters per second, and we have our bluish, purplish block stationary at 0 meters per second. I want you to predict what the collision will look like, or what the motion will look like for each of the blocks after they collide. And you'll do that for each of these situations. You can assume for the top 3 that they are they're not going to stick together. So you have to determine what their final velocities will be, which includes magnitude and direction. In the 4th collision, I wrote glue, so you can assume that these 2 objects will stick together after they collide. Now, if you open up my sample, so you can access the sample by clicking this. If you open up the sample, actually I will just open it, then you can go down to this slide, and you're welcome to just highlight it. So if you swipe from the bottom, like click and then drag over, you should be able to press Control C and then Control V into your notebook. And once you have that, you can add things like arrows, and I believe you can type in the arrow to indicate what you think the velocities will be. So maybe you think that this block will go from 2 meters per second to 1 meter per second after it hits. Maybe it'll slow down. And maybe this next one will be going 1 meter per second as well. Or maybe you think that they're going to reflect off of each other. Okay, now the text is going to be upside down. Well, you can add an extra text box, or you can just draw another arrow. Maybe you think they'll reflect off of each other at 2 meters per second each. Whatever you think will happen, put it down in the diagram, and you can also draw it on a piece of paper and then insert an image onto your slide. Or if you want to create your own diagrams, you can also do that. All right, so this assignment is 2 parts. So we have part 1, which is collision predictions, and then part 2, which is the simulation, or collision simulations. Now, in the prompts, you'll see, like, this is part 1, and then we'll scroll down, and now this is part 2. So follow the link to access the simulation. Click here. So I already have it open right there. You will complete 2 collision simulation tasks, one elastic and one inelastic. There are 2 groups, A and B. So in group A, so just figure out which group you're in, either A or B. And then you're going to copy and paste your designated table for each task into your physics notebook. You can copy the table by copying and pasting from this slide. So you can click here, and sorry about all the clicks to different locations. I thought you'd be able to copy and paste directly from the prompts, but we weren't able to do that. So that's why you have to go this extra step. So if I was in group A, I would copy this image for my elastic simulation, and I would paste that into my notebook. So Control C and then Control V. So Control V into my notebook. And then I also have task 2, inelastic collision, which means the 2 objects are going to stick together. So I'll find my letter, group A, Control C, and then I would paste that into my notebook. Alright, so now I will have my collision simulation open, as well as the task to complete. So task 1, we're going to have a slow cart run into a stopped cart. Now, let's see if I can make this a little larger. So this is the simulation. If I have a slow cart and a stopped cart, then I need my stopped cart to have a velocity of 0, so I can click these buttons. And I need my slow cart. Well, let's see how fast we can go in total. So 10 meters per second is the fastest. So to make it slow, I could make it like 1 meter per second. But it's up to you. The velocity that you have doesn't have to be what I have. As long as you record your information, then you're good. So I'm gonna do 1 meter per second, and this is how you change from elastic to inelastic, and this is how you start. So I'm gonna pause and reset that. So let's look at what information we actually need to fill out. So I need to fill out information about the mass, the velocity, and then I have to calculate the momentum. So I already filled this out, and what I recommend is just creating text boxes that are filled with a solid color so that you can write, so that you don't have to try to fit answers in those tiny lines. And so I have, if I were doing this for a 1 meter per second cart moving into a cart that is stopped, I have my positive, meaning it's moving to the right, velocity listed here. I have my 0 meter per second listed here. M subscript L just means the mass of the left cart. M subscript R stands for the mass of the right cart. And then the momentum calculation is very simple. It's just mass times velocity. The weirdest thing about momentum is that the symbol is P, but that's something you'll just have to remember. So PL, or momentum initial or before collision for the left cart, is just its mass, 1 kilogram, multiplied by its velocity, 1 meter per second. In total, 1 times 1 is 1, and the units are kilograms, meters per second. It doesn't convert into something like a Newton, it's just a kilogram meter per second. So you'll continue To fill out the chart, you'll calculate the final momentum by using data from the collision. So I could run this. It's gonna take a while. And this would be my final conditions. So now the mass, of course, will stay the same, but the velocity of the red cart is now 0, and the velocity of the blue cart is now 1. So I would fill that out here. So 1 kilogram times 0 meters per second is 0, 1 kilogram times 1 is 1, and the last couple of things that you have to do is just calculating the totals or the changes. So the total initial momentum is just 1 plus 0, so 1. The total final momentum, 0 plus 1, which is still 1. To calculate the change in momentum, you'll take the final minus initial for whichever cart you're looking at, the left or right. And then there's some questions asking about, so question 1 and 2 is just asking you to extract the info, like the calculation from your chart and put it here. And then number 3, was momentum conserved? How do you know? That is the claim that you're making. Was it conserved? Yes. Why do you say that? And use your data to support. Now, for task 2, I will bring this up in our next class, but something important, the final momentum for an inelastic collision, or when the objects stick together, it's going to be equal to the total mass times the velocity. So rather than multiplying the individual momentums, you're gonna well, actually, let me just show you. So if we change this to inelastic, and I'll just do some random velocity, so I'll press start. Well, you'll see that the two objects now move together as a unit. So rather than calculating the final momentum separately, you're going to calculate the momentum as if these were only one object. So they're of course going to be going the same velocity because they're moving together. So you're just going to find momentum, you're going to multiply the total mass. So in this case, our mass is 1 plus 1, so that would be 2 kilograms, times 2.5, since that's their velocity moving together. And I guess one other bit of info, if you're not sure what to do about the mass, if the picture shows those little black rectangles above the cart, then that means that it has some mass there. So you can look at the picture on the simulation, and this is how you change the mass. Oh, whoops, I need to restart. So this is how you change the mass. Just try to follow the picture. And I think that's it. So our next class meeting, I will go over a little bit, mainly the inelastic collision. You'll have a chance to discuss with your classmates that are also in the same group as you, either group A or group B. And then I'll be calling on some students randomly after they had a chance to discuss with other people in the same group. I'll have them share the results with the class. And I think that's it. So once again, this was for assignment number 2 on Google Classroom. And if you have any questions, just ask me when I see you next or via email. Thank you.